Now let's look at another example problem using 2 pointers. This is a LeetCode problem called the container with most water. So we are given n non-negative integers, a1 through an, and they represent I think it's better to view them as n vertical lines of height from n1 to a1 to an, and their positions are from 1 to n. So we view the x-axis as the bottom, and then we can choose two these vertical lines at the two sides, and then they form a container. And the goal is to find the container that contains the most water. So of course, when you have two sides of a container of unequal height, then it's the smallest height that determine how much water you can hold. So I think just like the saying, it's the shortest plank of a barrel determine how much water it can hold. And I guess just to be really precise, the problem says you're not allowed to slant the container. Yeah, so here is a sample input. So we're given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And the claim is that the container that can hold the most water is choose these two. So this has height 8, this has height 6, so that means we can use 6, and the distance between them is 1, 2, 3, 4, 5. So these container can hold 5 times 6, 30. And you can try some other, and you will find out that you cannot make a bigger container. So for example, the tallest this guy is 9, but if we use this 9 and this 8, the width of the container is only 2, so that's only 16, so that's smaller. And if this 4 and this 8, this will be I guess 7. Yeah, this might even be the second biggest. The width is 7 from 8 to 4, and the height is 4. So 4 times 7, 28, less than 30. So this is the biggest, and our goal is to find this. Of course, so this one is illustrating this. I have the height plotted here, so we're going to use this to illustrate our algorithm. So let's first try something really brute force. We just consider all pairs of sides that we can choose, and then we compute how much it can hold. So that will be j minus I times the mean of the height of this, and then we just keep track of the max. So this would work. So what's the time complexity of this approach? I think it's pretty obvious that this is n square, because this loop is executed n choose 2 times, and that each loop is a constant time, so it's just a simple operation. So can we improve the time complexity? Then if we are to improve the time complexity, basically we are saying that we don't need to check all pairs. So some pairs are known to be better than others. So let's see why that is the case. So let's look at this graph illustration. So let's say we start from both ends. So now from both ends we can form a container of width 9 and height 1. So this we can have a container of 9. Now the claim is that because this one is shorter, this one is bigger. So the biggest container we can form involving this guy is here, because anything else we use will only be will only have a less width, so the width will be smaller, but the height cannot get better, because if we use this side, then the maximum height we can get is 1. So the best container involving this is already considered, the 9. So we don't need to consider this guy again. So then we move the left pointer to here. So then we have a width of 8 and then height of 3. So we have 24 here. So again, because this one is smaller than the left one is smaller than this, we know using anything here paired with this will not be better. So we move the left pointer to here. We have a height 8. Now this and here, this one has width 7 and height 4. So this is 28. So this is, as we said earlier, probably the second best. And at this point, because this guy is the shorter one, we know using anything here pairing with this will only give us a container with a smaller container. So we don't need to keep this point. We can move this pointer to the left. And here it doesn't give us something better, and this one is shorter, so we move the pointer to here again. So right now the left pointer is pointing at 2. The right pointer is pointing at 7. So at this point we have a container of 30. So we remember this is the best we've seen so far. And this is still smaller. The right side is still shorter than the left side, so we keep moving. This will be worse. And then we keep moving here. When they are equal, I guess we can move either. So when we have a 2 and 5, because the logic holds, so either of this. So actually, I guess in that case, we actually can move both. So we actually can move in one step. We can move both left and right, but we don't have to. So so when we have left at 2, right at 5, let's say we move the left. So we are going to have this. Well, yeah. Then we move this. Yeah. So but we know we So yeah, so this will be correct. So I guess either will be correct. We can decide to move the left or move the right or move both. So all of this will be correct. So that's the basic approach. So these slides explain this the insights that we just discussed. So we can solve this using 2 pointers, and this is the code to do it. So we have a pointer I and j pointing starting at both ends, and we get the height, and then we compare. So yeah, I guess my code here is when it's equal, I'll be moving the left pointer. So yeah, so that's it. So to review, in problem involving 2 pointers, we maintain 2 pointers, and then we move the 2 pointers based on the values that they are pointing to. And when we can use 2 pointers, generally what happens is we are pruning the search space. So instead of considering all pairs, we can determine some pairs just won't work. So then we don't have to consider them. So by moving the pointer, we are basically pruning the search space, so that in the end, because every loop we will be moving the pointer at least one of the pointer by 1 step, we will be dropping the complexity from quadratic to linear. And another interesting problem that use 2 pointer is this USICO problems. So this is kind of I guess you can also call this 2 pointer essentially greedy, because we are saying we know those things won't work. We only need to consider these things are the possible. So this problem is an example of a greedy approach using 2 pointers. It's different because it actually has the 2 pointer pointing to 2 different arrays instead of pointing to the same array.